So I completely agree with this. My standard argument for going to space is, yeah, we want to survive, and we have a better chance to survive by spreading out. Because that, of course, means that local disasters become smaller, and even a local disaster on one planet, well, you can survive it if you actually do have a planet B. But supernovas, they're big, so now you need not just planets, but you need a solar system B. So generally, I think this is the morally strongest reason why we actually should work very hard on interplanetary and interstellar settlement. I think there are other moral reasons too, because we also have lives worth living, and there could be so many more lives worth living if we actually spread out. So right now, the surface of Earth, the biosphere, is a very, very thin layer. The total mass of the biosphere is, of course, by a normal individual human standard, tremendously vast, but is a tiny fraction of the mass of Earth. Indeed, if we rolled up the biosphere and all the water in the ocean and put them together, you would get a globe about the size of Spain, I think. Again, on an individual human standard, that's a very, very big globe. But compared to Earth, it's tiny. In fact, there is more water on many of the moons of Jupiter. So suppose we went to space and started to learn how to mine asteroids, to convert that metal into space stations, took the ice and the organics and turned them into soil and planted gardens and had animals and humans. How much more space would there be for humans and the biosphere? And it turns out that it's several million times more. You can scale it up, and indeed, if you start using the outer planets as raw material, now we're talking billions and trillions times more. It gets into these vast numbers that are simply inconceivable. There could be so much more future. And I'm still just talking about the solar system, which is a fairly modest solar system. The Milky Way got 300 billion stars, give or take. Some of them also much more long-lived than the Sun. I love to point out that although I like the Sun a lot, as a G2 star, it's kind of a fuel-inefficient star. It's not going to burn all its hydrogen. It's going to burn out in just about 5 billion years. While some of the small red dwarf stars you can see with a good telescope, they're going to run for trillions of years. Yes, they sputter a bit with flares and have other inconveniences, and you need to have a planet orbiting rather far in, and some of you might not like the aesthetics of a red light, but they're the little Volkswagen Beetles of the universe. They're going to keep on going for a long time. So I think we might also want to go there because we want a big open future. We don't really know maybe what the meaning of life is, but we're going to need a lot of time to find that out. We're also going to need new experiences. And I do think deep down we also need this optimism that there is an open future. That doesn't mean that we should say, yeah, there is a planet B, so we can totally skip caring about Earth, because most of us will never leave Earth anyway, because it's going to be darn inconvenient to get into space. Most of us are going to say, yeah, I'm not going to give up my little village. But some crazy people are going to do that, and we should be very thankful for those crazy people. Some of those crazy people are our ancestors who climbed down over trees or went out of Africa. And most of the sensible monkeys in the tree said bye-bye. And hopefully, of course, we can say bye-bye to the crazies, go off to Mars and later on to the stars. And then we should actually look forward to a really big open future where consciousness and life might actually spread between the stars and perhaps between the galaxies.
I have to add. I can add something. I think